Welcome to today's Explainer. We're diving right into a massive topic, how technological innovation is essentially the ultimate double-edged sword for our planet's future. Look, over the past few decades, we've talked a lot about the daunting challenges facing our world. Land degradation, climate change, water pollution. We see the problems, and we definitely understand the urgency. But today I want to talk about hope. I want to talk about actual solutions. Think of this as a masterclass on how technology, when we apply it correctly, is the key to unlocking a truly sustainable future.
Here is our roadmap for today. We're going to kick things off by defining the sustainability nexus, then we'll tackle feeding a growing planet, powering a clean future, cleaning up our mess, exploring ICT as the invisible connector, and finally we'll wrap up with the global engineering challenge.
Let's anchor our class today with a really powerful thought from the aviator Charles Lindbergh. He reminds us that technology isn't an end in itself, right? It's a tool. And when we wield that tool wisely and with real intention, it has the power to solve the absolute greatest challenges of our time. The exact same technology that pollutes our modern world can also help us build smarter cities and create a much more just, sustainable environment.
All right, part 1, defining the sustainability nexus, where innovation meets ecology.
So what do we actually mean when we say the nexus? The crucial emphasis here is on integrating both economic growth and environmental protection at the same time. Achieving our Sustainable Development Goals, our SDGs, requires us to effectively weave in digital technology. As the T20 South Africa presidency noted in their 2025 report, digital innovations present massive opportunities, but they also bring serious challenges, like huge energy and water consumption. Achieving our global goals means we have to purposefully design technology to solve problems, without creating new, unmanageable ones in the process.
If we break down the logic of innovation, it follows a really clear, almost mathematical path. Step 1, science. That's our engine of discovery. Those scientific discoveries naturally lead to Step 2, technology, which is just the practical application of that knowledge. And Step 3, when those technologies are guided by responsible engineering and interdisciplinary thinking, they yield sustainable solutions. That pathway right there is what allows us to use resources efficiently and actively protect the planet.
Moving on to part 2, feeding a growing planet, the agricultural challenge. We've got to apply this innovation logic to a very fundamental issue. With the global population hurtling towards 9 billion by the year 2050, global food demand is projected to rise by at least 60%. This forces us to completely rethink how we grow our food without destroying our land, water, and climate.
Consider these modern applications. Instead of relying so heavily on synthetic fertilizers that just wash off and pollute our rivers, we can actually use nature's own solutions. Take the field trials in India, conducted by the University of Cambridge, which showed that applying fungi-based biofertilizers boosted rice yields by 5 to 15%. Every single farmer in that trial saw an increase. Plus, we now have drone networks acting as advanced sensors in the sky to catch diseases early. And this is wild. Researchers at the National University of Singapore are developing dissolving microneedle patches that deliver beneficial microbes straight into plant tissue. It's literally like a vaccine for plants, using 15% less biofertilizer. This is precision agriculture at its absolute finest.
And the real-world impact of this is staggering. That same Cambridge research found that using smart, water-saving irrigation techniques alongside these natural biofertilizers can reduce harmful methane emissions by 45%. 45%! We are quite literally learning to use the soil's own biology to grow more food, but at a significantly lower cost to the environment.
Okay, part 3, powering a clean future, escaping fossil fuels. Our modern world runs entirely on energy. But right now, over 85% of our global consumption still relies on polluting, non-renewable fossil fuels. To really grasp how unsustainable things are right now, we can examine India's energy import dependency. Relying on external sources for 80% of its oil, 40% of its uranium, and 20% of its coal is a glaring vulnerability. The need to transition toward clean, domestically generated renewable energy has never been more urgent, both economically and ecologically. The incredibly good news here is that the solutions are already in our hands. While commercial solar panels sit around 10 to 15% efficiency, lab-scale efficiencies in the US and Europe are hitting 45%. The Nature Reviews Clean Technology series actually highlights that solar deployment is supplying 75% of electricity demand growth in 2025. We're seeing amazing innovations, from new German airflow technology that increases wind turbine efficiency to cutting-edge biofuel plants that process everyday garbage into fuel, potentially cutting global carbon emissions by 80%. And we absolutely have to mention India's Cochin International Airport, a brilliant beacon of engineering vision as the very first airport in the world to run entirely on solar power.
Which brings us to part 4, cleaning up our mess, environmental remediation. Look, while we transition to clean energy, we still have to address the legacy of the past. Before the Industrial Revolution, we lived in greater harmony with nature. But industrialization brought severe pollution, meaning we now have to use advanced environmental tech to aggressively clean up the mess we've made.
This introduces a fascinating emerging field called phytoremediation. Recent research out of Thailand proves that we can use nature to heal nature. By deploying specific types of plants, we can naturally reduce, remove, or completely detoxify hazardous environmental contaminants from our soil and water. The researchers note that the next crucial step is scaling this up from lab studies to massive, field-scale implementation.
But we aren't just relying on the biology of plants. We're engineering incredibly robust mechanical and chemical systems too. We're using membrane technologies and advanced oxidation to separate and destroy toxic chemicals in wastewater. We're outfitting industrial stacks with electrostatic precipitators to clean the air. And as highlighted by the 2025 International Conference on Pollution Control for Clean Environment, we are rapidly transitioning to circular economy models for solid waste. That ensures we actually recover useful energy and byproducts instead of just dumping our trash into a landfill.
Part 5. ICT, the invisible connector. We have to look at information and communication technology. This is the invisible digital thread that connects, coordinates, and scales every single sustainability effort we've discussed so far.
As the G77 statement on ICTs in 2024 emphasized, digital technology is a massive driving force across society. In education, government initiatives digitizing academic certificates are curbing fake degrees. In healthcare, telemedicine is allowing for treatment without the heavy carbon footprint of travel. And data sharing actually accelerated India's development of its indigenous rotavirus vaccine, which combats a major child killer. Look up at space technology. India's ISRO uses satellite data for disaster management and deploys the Navig navigation system, and they're even developing reusable rockets to lower the footprint of space expeditions.
But we have to face a really stark reality in our calculations here. 2.7 billion people. That is how many people are still completely offline worldwide. A 2025 bibliometric analysis on green growth warns us that this digital divide threatens to dramatically amplify global inequalities if we don't address it aggressively.
So we're left with a massive paradox. The digital world provides absolutely incredible opportunities for things like monitoring disasters and enabling smart grids. Yet the physical infrastructure of that digital world consumes massive amounts of energy. The endless rows of server farms, the growing mountains of discarded e-waste, the intensive resource extraction for modern electronics, these pose severe environmental threats. Technology can drive sustainability, for sure, but only if we engineer it responsibly and ensure everyone has equitable access.
Finally, Part 6, the Global Engineering Challenge. Your role. So, where does this leave you? The listeners, the future architects, planners, and engineers of our modern world. Because this nexus between technology and sustainable development, it's not a spectator sport. It is a direct call to action.
Your mandate is incredibly clear. You must design infrastructure that seamlessly integrates renewable energy and smart grids. You must build cities that utilize advanced tech for zero-waste water management. And importantly, research from 2026 confirms that achieving all this requires moving way beyond just raw technical knowledge. It requires you to apply ethical awareness, interdisciplinary thinking, and a steadfast commitment to equity as you innovate with AI, robotics, and automation.
Technology is not going to automatically save us. Remember, it is just a tool. I want to leave you with this final assignment to think on. Analyze a tool or technology you use every single day. Weigh its ultimate trade-offs. Does it truly contribute to sustainable development, or are its unintended consequences quietly costing us the Earth? Ask yourself how you will choose to engineer a better, more sustainable future. Thank you so much for joining me for this class, and keep questioning the world around you.